Hello, grade 9s. Today we're going on to triangles. And before I go on to these, I just want to show you or remind you what is the formula to work out the area of a triangle. So again, guys, this will not be given to you, so you need to know it. So the area to work out for a triangle is a half base times the height. Okay, so just write that down and highlight it. Now, to talk about what the base is and what the height is, I've got a few triangles here that we can have a look at. Now, the important thing with the base and the height, they must always be perpendicular to each other. In other words, they must make a 90-degree angle with each other. Then you can pick out the base and the height. So, for example, over here, this side here will be our base, and this line here will be the height of the triangle. Okay, and as you can see, they are perpendicular, 90 degrees to each other. Over here, we've got the base of the triangle times the perpendicular height of the triangle. Over here, you've got your base, and then you've got the perpendicular height. And notice with these three that I've just done here that the height and the base are all 90 degrees. Now, also another thing with these three things, these three triangles here, is the height is inside the triangle for these three. But it can be that the height is outside the triangle, like over here. Now, this is where you guys get confused, especially when it comes to exams and tests. You guys will use this entire length as the base. That is not right. The base is only that length over there, that line over there, okay? Then your height is this, just that line over there, whatever that length is, okay? So when you come to using the formula over here, A is equal to half base times height, you will only use this length over here for the base, and then that length over there for the height, okay? And we can have this where the height is outside the triangle because you can see that from the base is how high the triangle is. And remember that the base and the height need to be perpendicular, okay? So just remember those four cases and the area formula. When it comes to the perimeter, you don't need to know any of the formulas. Just remember what I do is I just add up all the individual lengths, okay? Now, another thing that you guys did last year was Pythagoras, okay? And remember, this is the formula for Pythagoras, where it's saying that the hypotenuse squared, now remember your hypotenuse is always the side opposite the 90. So your hypotenuse squared is equal to the sum of the other two sides squared, okay? And we're going to use Pythag to help us find the lengths of other sides. Right, so if we look at example 1, calculate the area and the perimeter of triangle ABC. This is supposed to be A here. Leaving answers in surd form where necessary. So first of all, let's just see that if we have all of the information. So we have the length of this side, which is 9. We have the length of this side, which is 7. But we're missing this side over here. So what I can do is I can use Pythag, okay? And now just going back to Pythag, remember that your hypotenuse squared is equal to the sum of the other two sides squared, okay? And that is what I'm going to do here. So this side that we don't know is opposite the 90. So that is our hypotenuse side. All right, so here we would get BC squared equals, then it's the sum of the other two sides squared. So we have AB squared plus AC squared. I'm just going to substitute my values in. So AB is 9, AC is 7, and we get that BC squared is equal to 81 plus 49. Okay, and then that means that BC squared is equal to 130 take the square root of both sides to get BC on its own, and we get BC is equal to the square root of 130, and it is centimeters. Okay. And they're just asking us to leave answers in surd form. And that is exactly what I've done here. I've just left that in surd form. Okay. So now I know the length of the side is the square root of 130 centimeters. Now what I can do is I can find the area. Now remember, the formula for area is a half base times height. And remember, guys, if I bring it back to this, your base and your height need to be perpendicular. So if I have a look over here, here's my perpendicular. So that means that this must be the base or this must be the base. It doesn't really make a difference. I'm going to make this one here the base. Okay, so that's our base. Then the other side that is perpendicular to that must be the height. So there's my height of the triangle there. Okay, the main thing here is that they are perpendicular. I can substitute this into the formula now. So we get a half, base is 9, times the height, which is 7. And what does this give us? This gives us 31.5 centimeters squared. Now also remember, guys, your units. Okay, so area is squared for whatever the units are. Now we can work out what the perimeter is. Now remember, we just add up all the sides. So if I start walking from here and I walk down, I've walked 9 centimeters. Now I've got to walk along here and I've walked the square root of 130 centimeters. Then I've got to walk back up here, back to the start, and we've walked 7 centimeters. Okay, we can simplify this to be 16 plus the square root of 130 centimeters. Okay, I'm going to leave it like this because the question said leave the answers in surd form where necessary. And that is it for that example 1. Okay, going on to example 2. It says calculate the area of triangle KLM. Okay, now this one looks very similar to this triangle over here, where we have the length of a base and then we have the height of the triangle. And as you can see here, the length of the base is only from there to there. So that is the length of the base. And then this is the length of the height. Okay, and again, you can see that the height is outside the triangle. So question A, area is equal to half base times height, which is equal to a half. The base is only 5 centimeters. It's just the length of this here, 5. And then the height is 6. Okay, and that will give us 15. And our units are millimeters squared. So there's our area for that triangle. Now what we need to do for question B is we need to determine the value of x, this value over here, and then hence calculate the perimeter of triangle KLM to 1 decimal place. Okay, so in order to find x, what I'm going to do, let's do it on the second part over here. To find this here, I'm going to look at this triangle as a whole. So I'm going to look at that, the triangle as a whole. And what I know is, I know that's 90 degrees. So I can use Pythagoras, okay? And remember that this is the side opposite the 90, so this is the hypotenuse. So the length of this side in total would be x plus 5 for whatever value x is. The length of that side is 6 and the length of that side is 10. So let's use Pythagoras. So it's m, and let's just call this o. All right. So mo squared plus ok squared will be equal to the hypotenuse squared, which is km squared. I'm just going to substitute the values in now. So the length of MO was x plus 5 squared plus OK is 6 squared equals KM is 10 squared. Now guys, remember that this is foiling. If you have something squared, it means 2 brackets and then you FOIL it. First, outer, inner, last. So I'm just going to skip that step because that was done last term. So this would give us x squared plus 10x plus 25. You can test it for yourself, just FOIL it out and you will get this. Plus 36 equals 100. Okay. If I take everything to the one side, we get x squared plus 10x. That is going to give us minus 39 equals to 0. This is a trinomial. We can factorize that trinomial. Again, guys, this is from last term. So we get x plus 13, x minus 3. So that means that x is equal to minus 13 or x is equal to 3. Now, which one is it? Well, it can't be minus 13 because having a negative length doesn't make sense. So this one here is not applicable. So x value is 3. Okay, so now we know that this value is 3. Now, how is that going to help us find the perimeter of this triangle KLM? Because now we need to find the perimeter of this inside triangle. Okay, well, we have the length of KM, it's 10. We have the length of ML, it's 5. We're missing this length over here, this KL length. So if I look inside this triangle over here now, I can use Pythagoras to figure out what KL is. Because I have this length is 6. I know this length is 3 millimeters now because we calculated it over here. We can use Pythag to find that. And I'm just going to use Pythag up here to show you. So we're finding, this is the hypotenuse again. It's opposite the 90. So KL squared will be equal to KO squared plus OL squared. KL squared is equal to KO is 6 plus OL is 3. So we get here KL squared is equal to 36 plus 9. So KL squared is equal to 45. So KL is equal to the square root of 45, and that is millimeters. So now we know that this length over here is the square root of 45 and it's millimeters. Now I can work out the perimeter of that orange triangle. So P is equal to, start walking from here, walk down, we walk 10 plus, I've got to walk across here, which is 5, plus, now I've got to walk back up to where I started, which is the square root of 45. Guys, you can just plug that on the calculator and you will get 21,7 millimeters. Okay. So as you can see, they can be a little bit involved, but if you keep to the method, you can't go wrong, guys. Right, so let's have a look at example 3. Calculate the perimeter and the area of this polygon. Now, this is when it starts getting a little bit hectic because we don't really know what this shape is. But what I can do is I can break it down into shapes that we know. All right. So for example, I can call this one shape 1, and that can be our rectangle here. Okay, so shape 1 can be the rectangle. Then I can call this one shape 2. And that shape 2 can be this triangle over here. Okay, and then this one over here we can call shape 3, which would be another triangle. Now, for these three shapes, we know the formulas for a rectangle, we know the formulas for a triangle, and likewise for another triangle. So break these shapes down into shapes that you know, okay? So if we've got to figure out the perimeter and the area, so let's have a look at shape 1. We got to know this length, which we do know. We've got to know that length, which we do know. So we can work out, or well, we don't know what that length is, but we know what that one is. It's 6. That means that this is also 6 centimeters because it's a rectangle. These sides are equal. So yes, I can work out the area of that one. Now for this one over here, what we need to know is the base and the height. So remember, look for the 90. Now it doesn't make a difference which side is the base and which side is the height, as long as they are 90 degrees. So I can choose this one here to be my base and this side here to be the height. This side over here, well, this length over here, well, if this entire length is 10 centimeters and that is 6, that means that this must be 4 centimeters, okay? Because the 4 plus the 6 will give us the 10. So I've got that one. Now I must just figure out what this length is over here. Now it's going to be a bit tricky because we don't know what this length is over here is, for example. But what I can do is we can maybe use Pythagoras or something along those lines to try and figure this out. Let's just have a look see here. So if this is 6 and it's got those double lines like that, that means that this one is also 6 centimeters. This one is also 6 centimeters. And this one is 6 centimeters. Okay. So if this entire length here is 20, that means that this one is also 20. So if this is 6, this means that this length here must be 14. The 14 plus the 6 will give us the 20. So for this green shape, or the triangle, we know the base and the height. We can work out the area. I'm going to come back to this one in a second, guys. For this one over here, we've got a base or a base or a base. We're just missing a height. Now, what I mean by that, if I had to draw this again, we know that all these sides are 6, 6, and 6, but none of these sides are 90 degrees. So what I need to do is I need to find what the height is. And I just draw a line from that vertex to that one and I make it 90 degrees. So this will be our base, this will be our height. Now in order to figure this out, what I need to do is I need to use Pythagoras, okay? So if this is 6, this entire length, that means that this length from here to here is 3. We know that one is 6, I can work out the height, okay? So that's your hypotenuse, it's opposite the 90. And all I'm going to do is I'm just going to call this h. So we've got h squared plus 3 squared equals our hypotenuse squared. Okay, so we get here h squared plus 9 equals 36. Take the 9 to the other side, and we get h squared is equal to the square root of, or sorry, it's equal to 27. So h is equal to the square root of 27, and it's centimeters. Okay, so now I know the height of this triangle over here. Now, what I need to make sure, guys, is I need to make sure that I have all the exterior lengths, because I need to work out what the perimeter is. So that length I know, that length I know, that length I know. Whoops, we don't know what this length is over here. So we can figure that out in a second. I know what that length is, I know what that length is, and I know what that length is. So let's work out what this length is over here. So again, this is your hypotenuse, because it's opposite the 90. So I'm just going to say here h squared equals 4 squared plus 14 squared. And we get that h is equal to, or h squared is equal to 16 plus 14 squared is 196. So that gives us h squared is equal to the square root of 212 centimeters. Okay, and I'm just going to leave it just like that. So now we have all the information that we need in order to answer these two questions. Okay, so the first one is the perimeter. So P is equal to, if I start walking from here and I walk along there, I've walked 20 plus. I walk all the way down here, which is 10 plus. I walk up here, which is the square root of 212. Then I walk down here, which is 6 plus. I walk up here, which is 6 plus. Then back to the starting point, which is 6. Okay. I can put that on the calculator and then just round off to say 2 decimal places, guys, and we get 62,56 centimeters. Okay, so that's that first question. Now here comes the big one. All right, what I'm going to do is I'm going to work out the areas separately. So I'm going to work out the area for shape 1, and we know that it's a square, so the area for that is equal to length times breadth. So our length here is 20. Multiplied by 6. And the 20 times the 6, we get 120 centimeters squared. So that is the area for shape 1. I'm now going to work out the area for shape 2, and because it's a triangle, we have to use the formula A is equal to a half base times height. So half. Now remember, your base and your height must be perpendicular, so let's choose this one to be the base because there's the 90. So that's 4 times, and our height can be 14. So we get here 28 centimeters squared, and that is the area for shape 2. Now we just have to do it for shape 3. Again, it is a triangle, so A is equal to half base times height, which is equal to half the base times the height. Now remember, we worked out the height over here, so that is square root of 27. And then our base is 6. Remember, it's the entire length. Okay, and what I'm going to do with this one, guys, is I'm going to round off this answer here. So we've got a half root 27 times 6. And round that off to 2 decimals, and we get 15,59 centimeters squared. So there's the area for shape 3. But they want the total area of this thing. So now I just have to add all of these things up. So we're going to add 120 plus 28 plus 15,59. And I'm getting those from here, from the individual areas. So we get 120 plus 28 plus 15.59. And we get a total area of 163,59 centimeters squared. And that is our final answer. So guys, with these ones, I need you to break them up. Expect something like this in an exam or a test. Okay. Right, so for homework, I would like you guys to do exercise 15.1, number 3, G to L. Thanks, guys.